Hey everyone, today we're going to talk about the differences between qualitative data and quantitative data. As we move through this course, it's going to be very important that we know how to categorize our data because what type of data it is determines basically what we can do with the data, how we can analyze it, how we put it into different graphs, what formulas we can use, etc. So let's look at this. Okay, so we've got two main categories, qualitative and quantitative. Think about those words. Qualitative as in quality, a quality or a characteristic of something. Names, smells, colors. Quantitative data, quantitative, quantity, scores on your exams, a 90, a 70, a 100, the weight of a pair of shoes, okay, your shoe size, what size shirt you wear. Think about the most recognizable difference between these two sets of examples. Over here under qualitative, all you see are words. You don't see any numbers. Under quantitative, exam scores, those would be numbers. The weight of something, that would be numbers. Shoe size, that would be numbers. So at its most basic form, that's a really easy way to tell the difference. Qualitative, we're usually describing a characteristic of something, where quantitative is going to involve numbers. Okay. So let's look at some examples. So a little overview, qualitative descriptions. Data can be observed, but not measured. If I'm trying to determine the smell of something, I don't measure that, I observe it. If I'm trying to determine somebody's name, marital status, married, single, divorced, I don't measure that, I observe it. Okay, so qualitative, quality. Go over here to our box for our quantitative. It deals with numbers, data that can be measured. What is your shoe size? What score did you make on your test? How much does your backpack weigh? So length, height, area, volume, weight, speed, time, temperature, humidity, sound, etc., etc. Quantity. So if you look at my first example, I have a picture of an oil painting, the exact same picture, but we can pull out qualitative data and quantitative data about this same item. So qualitative data would be things like it has green paint, it has a gold frame, maybe it smells old and musty, it has a peaceful scene of the country. Same exact picture, but if I was wanting quantitative data, I would say the picture is 10 by 14. In the frame, the overall measurement is 14 by 18. The picture weighs 8.5 pounds. The picture cost $300. So exact same painting, but depending on what I'm looking at about the painting, it could be qualitative data or it could be quantitative data. Let's look at another example. A latte. I know so many of y'all love y'all's coffee. Me personally, not a coffee fan. I'm addicted to Dr. Pepper, but no coffee. So let's look at the latte. Qualitative data. We could talk about the smell, the appearance, the taste, what color cup it's in. Quantitative data, we could say it's a 12-ounce latte. The temperature is 150 degrees. The cup is 7 inches high. The cost is $5. So once again, exact same picture, exact same item, but I can pull different data. Same thing at the bottom with our third example, the freshman class. I could talk about how many of you are male versus female. I could say that you had a positive school spirit. I could talk about your personality. Those would all be qualitative. Quantitative, I could say there are exactly 751 freshman students. I could divide it up into 320 girls and 278 boys. I could talk about what percent's on the honor roll. So, hope this helps you understand the difference between qualitative and quantitative, and also emphasize that the same item can have both. It's not an either or thing. So underneath qualitative, we have two subsets of data, nominal and ordinal. Underneath quantitative, we have two subsets, interval and ratio. If I'm going to, quote, rank my data, if I start at the left with nominal, that is the lowest form of data. And when I say the lowest form, we're talking about how we can deal with it statistically or mathematically. And then as I move across to ratio, ratio is my highest form of data. It can be manipulated the most. You can do the most with it. So let's talk about what each one of these mean. Nominal. Nominal data is when we have categories, labels, names, identifiers, things that can't be quantified, okay? So when I say it can't be quantified, I mean there's no better or best. So married versus single. Those are just characteristics or categories or labels, but married's not better than single. Single's not better than married, okay? So man versus woman, male versus female. They're different categories, but there's no ranking. One's not better than the other. If we take our data one step further to ordinal, ordinal has the same characteristics of nominal, plus it can be ranked. So I can say one is higher or than the other, or one is better than the other. So for instance, when somebody has you rate something on a scale of good, better, best, 1 to 10, 1 being the lowest, 10 being the highest, I can now rank those. I know that best is more than better, and that better is more than okay. But there's no meaningful difference between the rankings, okay? Not anything that can be quantified, okay? So I can rank them, but there's no meaningful numeric difference between the rankings. Move on up the scale to interval. So remember, these are building on each other. Now with interval, I can rank them, plus there are meaningful quantities between the rankings. There's a meaningful difference between the rankings. So for instance, let's say temperature. Temperature would be interval data. I know that 80 degrees is exactly 10 degrees lower than 90 degrees. So I can rank them. 90 is higher than 80, And I know there is an exact difference between those, an exact numerical difference. So see, when I go back to ordinal, I can't do that. I know when somebody chooses 8 on the scale versus 2, I know they think that 8 is a good bit better than 2, but I can't say they think it's exactly 10 times better or exactly 3 times better, because everybody's ranking that in their head. Okay, it's kind of arbitrary. But with interval data, I can rank them and there is a meaningful difference. I know that 1980, I know that sounds like a long time ago, doesn't it? 1980 is exactly 10 years later than 1970. So meaningful mathematical differences between the rankings. Then if I move to my highest form of data, my ratio data, I've got all the characteristics I've been building up to, plus anything that is under ratio has what we call a true zero or an absolute zero. So let's go back to the example I was just using with the years, 1980 versus 1970. That would be interval data, not ratio, because there is no true zero for time. Time has always existed, okay? Depending on your beliefs, how you measure it, before Christ and after death, or, however you measure it. Time has always existed. So there's no true zero. Temperature. There is no true zero because 0 degrees does not mean absence of temperature. 0 degrees is the temperature, right? It's cold. But -10 is colder. It's colder by exactly 10 degrees, but no true zero. So let's think about ratio, things that actually have a true 0 point. What about weight? Something can weigh nothing. If something weighs 0, it literally means the absence of weight. What about, money? Money has a true 0 point. If you have $0.00 in your checking account, then you literally have no money. 0 means the absence of money. So anything that has a true 0 point would achieve this highest category of ratio data. Okay, so you may need to pause and kind of think about that for a second and think about some of your own examples. I've got some examples for you. Nominal data, your nationality. What genre of music do you like? What's your hair color? What's your favorite animal? What are your favorite pizza toppings? Those are just nominal, right? They're just qualities, they're just characteristics. Then we have ordinal data. So remember, ordinal data, it can be ranked, but there's no meaningful difference between the rankings. So your socioeconomic status, lower class, middle class, upper class. Well, we know we can rank those, but there's not exactly $45,000 worth of difference in annual income from lower class to middle class. It's not that precise. Your opinion, agree, mostly agree, neutral, mostly disagree, disagree. We know that's a ranking, but you can't decide, you can't say if 2 people choose agree and other 2 people choose disagree, that there is an exact amount of disagreement that caused them to choose that ranking. It's an opinion, okay? Political orientation, time of day, these would all be ordinal data. What about interval? Remember, interval can be ranked, but there is no true zero. There's a meaningful difference though. So temperature, 10 degrees, 20 degrees, 30 degrees. We know there's exactly 10 degrees between those. So there is a meaningful difference, but no true zero. Time, dates, the pH level, it kind of just goes on forever, kind of like, time, kind of like temperature. Somebody's IQ, okay? Everybody has one. There is no absence of IQ. Some may be higher, some may be lower. We can find the exact meaningful differences between an IQ of 80 and an IQ of 100, but no true zero. Then our highest ranking is ratio data. Age. It can be ranked. I can find a true exact difference between a number of years, whether you're 10 years old or 20 years old. And there is a true zero. Temperature. Now, depending on how we measure temperature, okay, so this is kind of one of those, I put it on here on purpose to kind of show you, okay, wait a second. Didn't Miss Dancy mention a few minutes ago that temperature could be interval because there was no true 0 point? Oh, yes, I did. I'm glad you remembered. That proves my point. Some of these can be kind of confusing depending on how you're measuring the temperature. Some measurements of temperature do actually have a true 0. So don't worry. When I am testing you, I will make it very clear what we are talking about, okay? So I put that one on there just to kind of remind myself and make sure you are paying attention that some of these can be really confusing. But at this point in our class, we're just in chapter 1. We're going to keep it really simple. Distance, time, weight, okay? So there can be a true 0. Now think about time. If we're talking about time in one way, it might be interval. Time is in 1980 versus 1990. If I'm talking about time as in how long it took somebody to do something, that does have a true 0. So make sure you read carefully when you're looking at examples and that you really think about, is there an absolute 0 or a true 0? So I hope this has helped. We're just getting started, and these definitions, these terms, being able to categorize data, this is going to kind of follow us through the whole entire semester. So make sure you're understanding and keeping up. Thanks for watching, and let me know if you have any questions.